as we've seen, calculus is about the families of functions. It is about creating the connection from one function to another. And then in differential equations and in the fundamental theorem, we find initial values. So if you had the derivative equaling the cosine of x, and you integrate that, you get the sine of x. However, you get the sine of x plus c, because the derivative of any function that is a constant becomes 0. So without an initial condition, we don't know which of these 3 sine graphs we've created using our antiderivative. So the sine graph could be the purple, it could be the black, it could be the green, and it could be an influx of other sine graphs as well.
For that natural science lesson, we had a question about the building. The butterfly wings. I didn't listen to the whole question. I said sine graph.
Oh, there's quite a few out there today where I didn't read the whole question and guessed, and it ended up being completely wrong.
That I would have got if I read the whole question.
Right. Me and my dad both missed the hockey question last night.
Gordie Howe.
Yeah, I guess Brett Hall.
No, I knew Gordie Howe.
I was so mad. He guessed Bobby Orr, which was completely wrong because he's Boston. I was about to tell him that, but I didn't. But I know. Well,
The 6th decade.
what's wrong? Brett Hall played for a while too. So I'm yelling.
Not everybody has a wicked drawing their graph. See if you can read the next question. This story didn't draw his graph.
What do you mean? Look at this.
I mean, there's no points on there.
There doesn't need to be points. You can tell what they are.
They don't even know.
That looks like a soft fiction breeze, Corey.
Yeah. All right. So if you read on, it says if the cosine of x is 0 at odd multiples of what? When is the cosine of x 0?
2 pi, 3 pi, 2 intervals of 2 pi. Pi halves. See, there's a 2 and a pi in there.
The cosine of x is 0 at odd multiples of pi halves. Because if it was even multiples of pi halves, it'd be 0 and 2 pi. What?
-0. Yeah.
Oh no, it simplifies to 1.
I had to stop myself from finishing the book yesterday.
Oh, no, what a shame.
I am not that person.
There's 15 pages left.
No,
Oh, sorry.
I started this yesterday. As I was saying, I had to stop.
She goes, well, I didn't mean to call you.
It was
I was like, Dial.
So it
No,
says,
she wanted Mannion. So McBride and Mannion, I bet, on the call sheet are near each other.
so it says at odd multiples of pi over 2. But
Yes.
like 2 pi over 2 would simplify to 1, which is odd.
No. Like the numerator is odd. So like 1, 3, 5, 7, 2 pi over 2 would be an even multiple of pi halves. All right, I want my revealer because I want you guys to answer.
0.
Yeah.
Okay, so we should see that dy dx, or the slope at these points, would always be 0.
I can tell because it's an extrema.
Okay. It's an extrema of the graph.
No, that's not what I'm- if you take the derivative of cosine and sine, plug 0 at the sine, you're going to get 1.
But the slope of the line at that point is 0. That's because
the slope represents the derivative. Take the derivative of cosine, you get 1. plug 0 and you get 1, not 0.
But when you plug it in, the slope of that line is 0. The derivative is the slope of the line, not the y value.
So look at the graph. Well, your graphs are long. Look at the graph of
Nothing wrong.
the sine of pi halves.
At pi halves, the
At-
slope is 0.
That point, the slope is 0. So the derivative,
Oh, okay.
remember we graphed sine, so its derivative at that point is 0.
Which is
Because the
cosine.
cosine of pi halves is 0. We're talking sine, cosine's the derivative. You're trying to flip it.
Yeah, I see that now.
Okay. You had it backwards in your head. What you were saying was right. Your argument was correct, but you're arguing the wrong example.
Yeah, I see that.
All right. Yes. Algebraically, the y coordinate does not affect the value of dy dx in this case. Why?
What is what?
Why does the y coordinate not affect the slope in this problem?
Because it's a sine graph.
Well,
Because
and
there's
think
no-
about
there's
what's
no-
the derivative of y,
dy dx.
which is always going to be
1.
so it's unaffecting. Anything times 1 divided by 1 is unchanging. So the y value doesn't affect our graph because the y value's derivative will always be 1, which will unchange anything happening with x. So going up, going down, the slope isn't going to change because that's a 1. Plus c that would affect the y value will automatically zero out. Right?
Yeah, but like I don't like it because it's not what I was expecting. Like when you fit into the compared by a 1.
I didn't know
I
that.
did not do that.
I did not.
It's just unusual. It's not what
Okay.
you expect.
Does the graph show that the y coordinate does not affect this? So if you look at the sketch and the curve I had you draw, can you see how it's unchanged by y? Yeah.
Move it up or down. The integral would change.
Does the graph show that the y
So
coordinate?
exactly. The slopes are only equal to the values of x. So if you plug in x equals pi fourths, the slope is affected by x, not by y. And when I talk about plugging in slope and x, we're talking about the derivative or the original, not the integrated sign. So if you talk about the differential equation, so it's a differential because it's dy dx, what should the slope of the solution curves be when x is 0? So what is the cosine of 0?
1.
1. Look at the graph of sine. What is the slope of sine at 0?
1.
So the derivative graph gives you the slopes of the original. Derivative graph gives you the slopes of the original. So we are going to create slope fields today using the derivative to try to predict the original.
The original slope or the original point?
The original graph. The original graph. So what is the cosine of pi?
Well, I gotta read this.
No.
Cosine of pi is negative 1.
So go to the sine graph at pi.
0.
No!
That's negative 1. Dick. What?
You have to look at the slope.
Like, is the graph of the sine at pi going down, going up, or horizontal? Therefore, it would have a slope of negative 1.
I'm getting there.
The cosine of x is considered even. The cosine graph of x is even. The sine graph of x is what?
Odd.
Oh.
Odd.
Hold on, I gotta write some stuff down. Well, you don't show us until you start the next question.
Because I want you to think. But don't think like Cordy.
Okay, but then you start the next question without letting me write.
Maybe you just shouldn't get up.
What's the matter?
This is, I feel like, helpful but kind of confusing. Like it takes a second read.
Yeah.
Can you make any more noise?
Really cute. Did everybody get their college?
Yeah, make sure I ask you what college she was going to, and I was like, I don't know.
Yeah, because they already got the cup order. She just decided that last week.
All right. So we can take these concepts and these ideas, and we can take a derivative and create a slope field. So slope fields come from differential equations. Slope fields come from differential equations. So they come from dy dx. A slope field will predict the original equation as its family. So a slope field predicts the original equation as its family. A slope field is what we call a directional field. So this is a slope field.
What is a slop field?
Filled with a bunch of slop.
Where do I have that?
The end of the first paragraph.
Am I just supposed to draw them?
We're going to do your example.
Oh, okay.
Oh, this reminds me of AP too.
I was saying this looks like magnetic fields.
All right. So we could take the ideas
Which I don't
explored above
understand.
and use them to produce a graph for any differential equation. Remember that the derivative gives the slope at any point. A slope field is a first order differential equation. So if you looked at this graph, what is the slope at x equals 0?
First, I'm gonna let someone else answer this one.
What is the slope
0.
at x equals 0? Okay, on all of your papers now, put a horizontal little line at x equals 0. So you are recreating this little blue line right here.
So do you want us? So do you want us to make?
Yeah, that's
those
fine.
little lines?
Once you said that, we can do this.
Do you want us to make all those little lines?
Eventually, we're going to, yes.
So we're starting with our horizontal lines right now.
I'm walking you through it. Like she said she was trying to copy them, but I was going to work through it with you. All right. At y equals 0, what do you notice about all those lines?
They're vertical.
They're vertical. So that means the slope at y equals 0 is, go ahead, undefined.
Undefined, yeah.
So what I'm doing is we're kind of going through and talking about the points. So at like 0, 1, we said the slope was 0. Conversely, at 1, 0, we said our slope is
Undefined.
oh. So then, what about at the point 1, 1?
-1.
Okay. So at 1, 1, our graph appears to have a slope of -1. At 1, 2, would you say the slope is the same?
I'd say it's negative.
Or, sorry, at 2, 1, I wrote that backwards.
So much parabolic.
I'd say it's better now.
I'd say
At 2, 1.
negative.
So would it be steeper or not, or less steep? And is it positive or negative?
It's negative.
It looks more steep.
It looks more steep, correct? I agree with you.
So -2.
Yeah.
But it almost looks parabolic in nature.
Maybe that was just for line.
We're grading for art in math class.
Now,
What about my Picasso drawing?
what if I went to the point 1, -1? And how about the point 2, -1?
-2. No, +2.
Freaking idiot! Alright, calm down.
So what are you noticing about as we're working our way out?
They are flipped about the x-axis.
They are. So if we tried to create a relationship between these, x and y are both positive, and my slope is
Negative.
okay. So that means if I have a dy dx, it probably needs to have what in its answer?
Negative.
Yeah, because if x and y are both positive, I need it to have a negative. If you put 2 over -1, you get
Positive.
2 and then times your negative, right? So this equation is x over y. Does anybody remember what derivative has an equation of negative x over y? It was an implicit function we derived many times.
Is it 1 over x? Hold on, let me think.
What does this graph appear to create a shape of?
Oh, it's a circle graph.
If you picked one point and connected your dots, so let's say I started at this point, and you follow the slope of the lines, you pick a smaller point.
No, I want a donut.
Sprinkles. So integrate backwards. Like find the integral of dy dx.
Y dy equals negative x dx. So y equals negative x squared over 2.
Y equals plus or minus the square root of negative x squared plus
Y
c,
squared over 2.
which is a circle of radius c. Well, c squared.
Interrupt, you know what C and I was thinking of yesterday? Napoleon Dynamite.
You can also think of it as x squared plus y squared equals c, which is more often how we think of a circle equation. I just ran out of room. Because you would add the x squared over, and again, it would be the square root of c. Good? So that's how you go from a slip field to your differential. Let's look at example 7. Right? So example 7 says plot the slope field of the differential equation dy dx equals 2y. So again, we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you have a 5 by 5. So we're going to create the slope field for the 5 by 5, picking points on the line. And thinking about what I thought about in this problem, there's certain points that are always going to be the same, regardless of the y. So in this case, which one is affecting the graph? If it's dy dx equals 2y, does the x value affect the graph or the y? So it's the opposite of the cosine graph, right? So now the x should not matter at all. So when you're plugging in, what are you plugging in? So that means that at y equals 2, all of the slopes straight across for x are going to be
0.
the same.
Yeah. What I said.
So in this previous example, I had x comma y, and that's what I plugged in to get the slope, right? But we were working backwards. We had the slope field, and we figured out the points. This time, we're going to use the points to figure out the slopes. But in the case of this problem, the x's don't matter because there's no x to plug into. So we're going to look at y equals, do you want to start at the top of the slope field or the bottom?
Bottom.
-2, -1, 0, 1, 2. Because again, the x's are unchanged.
So -2 should be -4.
Okay. -1.
0, 2, 4.
Yeah, I take that back. I think it made more sense to start at the top.
I'm starting in the middle.
What do you mean, dude? It doesn't matter.
It doesn't. All right. So the easiest one to put in is 0, right?
Yeah.
A slope of 0 is
0.
horizontal little lines. What you need to do or indicate in your slope field is to try to be consistent. If it's a slope of 2 and a slope of -2, they should have the same steepness, just one going up and one going down.
I'll try my best.
Y equals 1.
And then your 4 and -4 should have similar steepness, but in opposite direction. And it needs to be steeper than the 2.
Remember, we should have paid attention to the last year.
Yeah, I live with a couple of guys.
Okay. So then as a
Ellen.
follow-on to that, suppose that you want to know the point 0, -1. So where is 0, -1 on our graph?
On the y-axis, down 1.
So when x is 0, y is -1. It's right there, right? Just like we did in the previous example with the circle, follow the slope field. Sketch in your graph.
Was I right?
Yeah.
1 over x.
We're gonna solve it.
Well, it's one of those two.
Okay, in example 9, so I don't know why I didn't keep it on the same page, but you could do it on 8.
I think it is long.
In 9, we're going to actually find the equation.
Log x? I should just spell it the word log.
Okay.
Which
So
is all-
dy, so now we're doing what we did yesterday, the differential, example 9. So dy dx equals 2y. So now you're going to find out which one of you is right, or if neither.
No, I'm right.
So how do you integrate? You have to,
dy equals 2y dx.
but you need your dy's and your y's to be together.
Well, I'm getting there. I don't like skipping steps. dy over 2y.
Oh, I left the 2. You can bring it.
dy over y. You know what dy over y is, Corey? ln.
Except for it's the ln of y, and we need y ln.
I don't care.
Yeah.
Still ln. So it's going to be an e graph.
Yes.
Oh.
Yes.
I was still on the right lines.
All right, so you integrate 1 over y, then you integrate 2 dx.
So you get ln
And you
y equals 2x. So then y equals.
2x plus c.
So is the plus c in the exponent of e?
Yes.
So y equals 2x plus c. E to the 2x plus c.
Yeah.
That's what I meant.
But this is where you asked me about the absolute value of y. This is where it's going to come into play. Because our particular solution was on the bottom. Therefore, we're going to need a negative in our final answer when we find c. So, like,
magically get rid of the
No,
absolute
it's going to go over as a plus minus. Because there's only one absolute value this time. So how do you solve for y?
Eat it.
E both sides.
Eat it. Crap.
But when you e both sides this time, it's y equals e to the 2x plus c.
Y to the
However,
2x minus c.
It's a plus or a minus e until we figure out. Now, what do you know about powers to powers? If you had a to the m plus n, what's that equal to?
A to the MN.
A to the m times a to the n.
I knew that?
Yes.
A man. That's what it is. A man.
A to the m plus n is the same as a to the m times a to the n. Because, think about if you had x squared times x cubed. What do you do with those exponents? It would have been better if I had an ADAM in there. I'll do it again next time. Yeah. Okay. You just made me so happy. I'm going to totally change the way I teach this forever now. I'm going to make it.
Adam Tetris.
You add them.
You add the exponents. Oh my god, why has nobody ever thought that?
Let's see if anyone catches it.
That's online.
Well, I did just.
I know. I should just take a video for it. I'll just come. Then I can just.
Viral on that.
Then you can teach every class and not have to worry about nothing.
Okay. So what are you going to do to this problem? What we're going to do is we're going to bring that C down. You're going to do this every time you have an E with an ln now. So we're going to rewrite them as y equals plus or minus. Technically, this is e to the 2x times e to the c. But e to the c is really just a...
Constant.
So we don't know our constant of c yet. So we're going to rewrite it as c e to the 2x. So anytime you ln, and then what you're going to do is solve for c. Because c represents the initial condition of an exponential function. C represents the initial condition of an exponential function, right? Y equals y naught e to the kt. So in this case, we were given the point 0, -1. Is that not our initial condition? So if you were to use that example in 8, -1 in for y. Anything to the 0 power is
1.
ooh. So my C value is equal to, and that should make sense to you because the E graph is reflected and down in our slope field. So the slope field equation that we sketched was y equals -1 e to the 2x. Because the C value is the initial condition.
Why
On
can't you
an
just bring
X.
that C down in front of that?
Because this is e to the c, which we, like, if you made this, if you left it as e to the c, then you would have had
ln y.
-1 equals e to the c, and you would have ln'd it, and then to get the c alone anyways. And what happens is sometimes you can't ln to solve because it's negative. So they've discovered over time that since e to the c is a constant and c represents a constant, and it represents the initial condition, it's an IVP, it's an initial value problem, and that c value in front of the exponential is always y naught. Somebody did this whole long proof that proved that. I don't know the whole long proof.
You can't recite it
I
off
don't
memory.
miss proofs. That was terrible.
I love proofs.
I like reading proofs. I don't like doing
Let's
that.
do another example of a slope field.
I agree with that.
Do another slope field?
No.
No.
Read them.
Well, I think you agree with me. Slope field.
Well,
This
I think
dy
this-
dx is equal to this dy dx is equal to x minus 2y. So now
Why can't I just integrate?
both equations are affected, right? Or both points are affected. So you need an XY table. I feel like this is very complicated to explain.
You're telling me.
I feel bad for Des.
So you pick a point,
She's got 92 in this class.
you pick a point and start there. So we could pick 0, 0. You can pick 1, 0, you can pick any points you want. So I typically start at 0, 0 because what's nice about 0, 0?
0.
So that means this is. So then if you move up and you go to 0, 1.
Wait, why don't we do the integral first? I thought we had to do the integral first.
No, we're making a slope field. We don't have to do an integral at all. 0
But we did an integral last time.
minus 2.
Are we gonna have to do this for every single point on this 25-point chart? Oh, we are.
Still 8 points, wasn't it?
The circuit.
Packet, yep.
Yeah, I just didn't change it.
Why, Deja?
So what's nice about this is they end up being
Reciprocals.
something like that.
I hope the point we're looking for is not in the second or the third or fourth quadrant.
This one's outland.
Yeah, this one's
1.
This is a circle. Nope. I'm telling you. It's a parabola.
I think this one's actually a cubic.
Cubic. Alright, I'm with Corey. Are we actually doing this 25 times?
Review.
This is just the monotony of doing this 20, because it actually would be 25, right? 5 by 5. So we'd have to do this 25 freaking times.
How many freaking times?
25. I'm not doing this 25 times. I'm just going to watch her do it and then write the line.
Well, Corey, this is why you're not going to do good on your next test.
Yeah, so we're drawing out all 25 boxes on the test.
This is why I'm
You get a point for each box you draw. Correct or incorrect?
This reminds me of the game that me and Des were
So now where'd
playing.
you go next? 1-1? Yeah, she went 1-1. Of course she did.
Alex, this reminds me of the game that we played with the squares. On the board, we used to complete the squares.
I know, and you guys were playing it that one time. I was like, oh my gosh, that's so much like a slope field.
That should be the bonus point. Whoever can win the tournament of squares.
Me! I beat the snot out of you.
Stop.
First place gets 3 bonus points. Second place gets 2. Third place gets 1.
One person, 2 people get left out.
2 people don't.
No, we need to make a 4-3-2 and one person gets screwed. Unless I'm 5.
Like a very
So
complicated.
do you see like a pattern involved?
Not exactly. Well, maybe because your head's in the way.
Maybe you should do it yourself.
You didn't do. You graphed 2-1, but you didn't put it up.
I did it in my head.
It's 0.
Now you got 6.
2, 1.
Yeah, 2 minus 2 times 1.
2. Oh, maybe I did accidentally graph that.
Now I really don't see a pattern.
Yeah, I don't see it.
Hold on, let me get there. I'm not there yet.
We need a few more.
I only did the top right corner quadrant. I gotta get to the top left now.
0? What?
Stop talking. I'm telling you, it's a circle.
There's no way that thing's a
It's
circle.
not a circle.
What was my original guess?
LN.
No, that's not it.
Mine's cubic.
No, it's a parabola.
It's not.
Squared over 2. Square root of x squared over 2. Square root function.
Square root function. Maybe.
It is. Because when you solve the integral, it's a square root.
You cheater. You can't solve the integral. You gotta look at the graph.
Why? That's stupid when I can just solve the integral.
Because that's cheating. I'm gonna send you in the same cheating boat as Des.
No, I didn't use my calculator. I did the math.
That was Deja. Deja, plug this into your calculator, see what it is.
Really, scumbag.
This is bad. Solving the integral when I'm trying to look at this.
Wrong way.
Hieroglyphics.
What kind of glyphics?
Cairo. It's in Cairo where they were created.
I don't think that's true.
I could not figure out how to spell Giza yesterday.
G-I-Z.
That was a Y for the longest time. And now I got a few like X's in here because Miss McBride drew them the wrong way.
So this is why she's not going into the negative quadrant. Never mind.
Negative quadrant. I'm running out of room.
Yeah, me too.
Well, that's what happens when you have to do 25 thoughts.
I feel like at some point I used a calculator in the past.
I feel like at
Just
some point
wanted to
you're
make
right.
you.
I feel like this is a calculator problem.
I feel like I should be getting a bonus point for writing this whole thing out.
You should just shut up and keep writing.
I feel like I'm gonna punch you.
Don't safe. Just say.
Does that thing still exist?
Yes.
Absolutely. Yeah, Riley Stoppard got reported last year.
We're still missing some.
I am aware.
And at this point, we might as well finish.
I am.
Wait, wouldn't negative 2, 1 be 0? 2, negative 2, negative 1?
Negative 2.
Or
Zero.
Oh, negative 1, negative 1. Never mind, I did my math wrong.
I'm not there yet.
I'm saying
I know, I did negative 2, negative 1, but graphed it at negative 1, negative 1.
Oh, I was like,
This is square root graph, though. How are we going into the negative quadrant?
square roots can be negative. The square root of negative something is negative. A reflected square root graph.
Square root of negative x can't be done.
Oh, you're talking that square root. I meant like a reflected square
No,
root.
no, no. I'm talking about how are we going negative x-axis here with the square root.
Wouldn't
I need to do
why
minus 2
negative
points.
2 be like a negative slope?
1,
Minus.
That's
negative 2.
I think that's one of the
Positive. 1
One.
minus two, a negative times a negative.
Yeah. Yeah.
Oh, true, true, true.
Yeah. All right. Negative 2 minus 2.
Negative 4.
Are you
All right,
done,
I'm
Deja?
done.
This is
Hold on, I'm not done. I don't quit on this crap.
There you go.
Here, look at mine. Perfect. Just a few x's. Okay.
Anti-derive.
Wait, shouldn't negative?
We'll do it on the back just because now don't you want to know?
Well, I already do know. It's the square root of x squared over 2.
X minus 2y. X minus 2y. X minus
Wait, hold on, I wasn't done with that.
So I do see a
2. Fine. I'll do it over here.
Negative 2, negative 1, it's negative 1, negative 1. Ouch.
Whoa. Are you? They're like glitched on me.
I only got 1
See,
point.
it's going to be difficult. No, it's
A problem I don't know if you can actually integrate.
Well, I did, so I did.
but I don't think you integrated correctly
Yeah, loser.
because
Because
you're
it's 2y
they're-
plus dy.
Yeah, because they're not separable.
Oh.
This is where you have to get into partial derivatives. That's why this is the type of question they would put on the AP exam. because you can't integrate it to know what the function is. And that's also why it doesn't look like a function you know readily.
Yeah, that looks like
What does it look like? Because now the only pattern I see is the straight lines that go across at that pattern. That's it. Everything else looks like a bunch
Well,
of.
then I am a super genius.
You are Mark Madden.
It's a variation of a cubic.
Let's go! I said that.
It's like so not x cubed, but like a cube root. Because it's think about this. It's gonna look like these are your horizontals. So it's gonna do something like this. Yes. All right. Your homework
The point for that.
is slope fields.